Hello everyone, welcome back to my channel. Today in this video, I'll be discussing about a DSA problem, middle element in the linked list using Java. So I'll discuss about the problem statement. I'll discuss about the constraints given, what are the examples, I'll take the input and output, and what are the scenario given. There will be two scenario, one for odd number of node in a linked list and one for even number of node in a linked list. So I'll discuss all those things and then I'll solve the problem in Java. So let's get started. So here is the problem statement. This is problem number 876 in the lead code and the problem name is middle of the linked list. So let's go through the problem statement and then I'll go through the example given here. Then I'll solve the problem. So problem statement is given the head of a singly linked list, return the middle node of the linked list. If there are two middle node, return the second middle node. So problem statement is saying that you are given a linked list and you are given head of the linked list and you have to return the middle node of the linked list. And if there are two middle node, then you have to return the second middle node in the given linked list. So I'll discuss about example given. So example number 1, where you see the linked list is 1 2 3 4 5 and 3 is the middle node. So in input it is given head is equal to 1 2 3 4 5 and output is 3 4 5. And in explanation you can see that it is saying that middle node of the list is 3 because there are odd number of node which is 5, and if we find the middle node from these 5 node, you will find 3 is the middle node among all of them. So this is the first example when node is odd. Now let's see the second example where the number of node is even. So there are 6 nodes. So here you will have two middle nodes. One is 3, one is 4. But in the problem statement it is already mentioned that if there are two middle node, you have to return the second middle node. So here you can see that there are 6 number of nodes 1 2 3 4 5 6 and middle node is 4 because here in this case there will be two middle node 3 and 4, but I'll be returning 4 because it is mentioned in the question, because it is mentioned in the problem statement. So this is about the example given, and now let's come to the constraints of the problem statement. So the first constraint is the number of node in the list is in the range of 1 to 100 and 1 and 100 both are inclusive. And second constraint is node dot value should be greater equal to 1 and less equal to 100. So these are the two constraints. So this is all about the problem statement. If you have not understood anything in the problem statement, you can let me know in the comment section. I'll be happy to help you out. So now let's move to the right side of the screen where I have this editor where I'll be solving this problem, and I'll be using that language is Java that I have already explained in the beginning. Like this video is going to be in Java. So let's see. Let's see how this problem will be solved, and I'll be solving by using a two-pointer approach. Just to let me tell you in brief, where I'll be using a two-pointer for iterating the linked list, and then using both the pointer I'll be finding the middle element. So let's get started with the coding. So I'll first declare two node. I'll call it slow and I'll initialize with the head, and then I'll call another node fast. This will be also initialized with head. So I have taken two pointer, one is called slow and one is called fast. and I have initialized both the pointer with the node given as a parameters in the function. So now I need to iterate the linked list in order to find out the middle element. So I'll be using while loop, and in the condition I'll be giving the condition first not equal to null. It will run till the first is not equal to null, and first dot next not equal to null. So this is the condition, and I'll iterate the both the pointer. So slow will move slow dot next, and fast will move fast dot next. So here you see I am just incrementing slow pointer with just the next, and fast pointer with the fast next to next. So slow pointer will move one node and fast pointer will move two node. And this is the logic which I am using in order to find the middle element. So when we move these two pointers slow and fast from the beginning of the list, which is nothing but head, and till it reaches the fast dot next is not equal to null, my slow pointer will be at the middle element and fast pointer will be at the last element. So we know like slow will be at the middle element, so we'll return the slow pointer after that. So I'll return the slow. So this is going to be my code for this problem, and let's see that I'll submit this code and see that whether it is getting submitted properly or not. So let me submit. So here you see I am able to submit the code and it is accepted. So this piece of code which I have written on the screen is working as expected, and so I hope that you are able to understand the code. If you want to get it more in detail, you can connect me on this page. You can book a discovery call. I'll put the link of this page on the description section of the video so that I can discuss with you in a detail, and I hope that I was able to make you understand. If you find this video helpful, don't forget to like, comment and subscribe to my channel. Thank you for watching. I'll see you in the next video.